So this is about where we were last time, right? Int sum. But before that, I want to make sure something's clear. With the while loop, a while loop, like the examples I showed so far with the while loop all used a counter because I wanted the loop to run some number of times. But a while loop doesn't care about what the condition is. It doesn't matter. All that matters is that's a Boolean expression that evaluates to a Boolean. If it's true, the code executes. Otherwise, it doesn't. That's all it is. So here's an example of a while loop that'll keep asking me for input until I say James. It finally stops. All that matters is that it's some Boolean. The while loop doesn't care what the expression is. It doesn't care what the comparison is. All that matters is that it gets a Boolean in the end. And if the Boolean is true, then it runs. That's all, just to make sure that's clear. And then last time, we were talking about int sum, right? And so here's my int sum. This is code that will add all the numbers up from 1 to, or 0 to whatever I add inclusively. So if I put in a 5, it'll add 0 plus 1 plus 2, 4 plus 5. And if you had a difficult time with this, see, people will look at this, and one of the areas people start to get thrown off by is like, well, how did you know you need like a counter and a running total variable? I mean, you're not supposed to look at the problem and know immediately how to solve it, right? I just thought, well, what do I need? Well, I want a loop that's gonna be this isn't even correct. We didn't even include n. There. Oops. I want a loop that's going to, look, I want to add 1 plus 2 plus 3 plus 4 plus 5. So I need a loop to run such that the first time it runs, I've got a 1, then a 2, and then a 3, and then a 4, and then a 5. Okay, that's counting. I can do that. So I had a counting variable that went up to n. But how did I know I needed a running total? Well, I didn't immediately know. I just thought, well, I'm going to need to keep track of some running total, so I guess I'll just make a variable for that. People will be apprehensive of adding a new variable, but you don't have to be. You can have as many variables as you need to solve the problem. Do what you got to do. Remember, you're the god in your world of programming. What you say goes. What the code you write is what the computer does. It listens to you. If you need another variable, add another variable to keep track of some value if you need it. Good. So don't be afraid of the loops. Just use them like you've been doing everything before. If you need a variable to keep track of something, do it. Simple as that. So here, okay, no, we'll skip that one. So, algorithm. Every piece of code we've written so far has been an algorithm. Right? It is, by definition, an algorithm. But as we start writing more and more complex chunks of code, it becomes a little, people tend to be a little bit more comfortable pointing at those chunks of code and being like, yes, there's an algorithm that does X, Y, Z. Everything we've done so far is an algorithm, but I know that, like, we're at the stage where, okay, I wrote a function that sums up all the numbers from 1 to n, right? You know, that's an algorithm. We're easy, we're comfortable with that, calling it that. All an algorithm is, it's a recipe. And I'm not being silly with my terminology. It really is it. If you've ever baked a cake, you've followed an algorithm. It's a step-by-step set of instructions that can be followed to do something. It's an algorithm. All recipes are algorithms. We just don't call them algorithms. But they are. That's like the mathy word we use. Algorithms can be explained in natural language, like English, like how to bake a cake, how to drive to work. Right? Or it could be written in the formal language like Python. It's just the mode of how or the medium of how like the algorithm is being communicated. Finding algorithms to solve a problem, coming up with an algorithm to solve a problem is not trivial. The whole, like I've been saying before, your job when you're given a problem, your job isn't to sit down and write the code for it. No, that's the last thing you got to do. It is, what is the problem? That's your job to figure out. Next is, how am I going to go about doing this? You come up with the algorithm, because the algorithm in the code, don't conflate those things. The algorithm is the step-by-step set of instructions. The code is a way to write the step-by-step set of instructions. But the algorithm, the way you're going about solving the problem, is independent of the code. So you need to understand the problem, come up with your algorithm, come up with how you're going to go about solving it. Then, if you try to do it in another order, it's not going to work very well. So here, we'll start by first, take a moment. You can talk amongst yourselves. I don't care. You can just write it down for all I care. Think of the step. Look, you have to write a function to count or to add up all the even numbers between 0 and n, okay? That's an easy problem to understand. Add up 2, 4, 6, 8, and so on. Only the even numbers up to some value. So first, explain in English to yourself or someone else, write the algorithm in English, then do it in Python. I'll give you a few minutes for this one. It's the exercise of understanding that the code and the algorithm are separate. So here's my implementation. And you could raise your hand if yours looks basically exactly like this. Really high, I want to see. Okay, cool. I'll talk about an alternative in a moment. You look at this and it's immediately, like even just from looking at the code, we're going like, okay, now we're kind of like, this function's getting a little complex. Because we've got a while, but then we have an if and a while, which isn't too bad, but I mean, we've got these two special keywords, but here's all that's happening. In fact, let's go look at what I wrote down in like my English description. Start with a running total of 0. Start at 0 and count up to n. If the number is even, add it to some running total. And then when you're done, return the final result. In fact, I could even like, look, it's even kind of, here. It even kind of looks like the code now, just how I formatted it, right? But there's my code. What do? I start with a running total of 0. I have a current number starts at 0. Well, the current number is less than or equal to n. If the current number divided by 2 has a remainder of 0, it's evenly divided by 2, meaning it's even. So if that condition is true, add whatever value the current number is to the running total. And either way, whether or not the number is even or not, I still have to add 1 to the current number, right? Because it goes 0, 1, 2, 3, 4, 5. So whether or not the if statement runs, I still need to make sure I'm updating the current number. So here's one working solution. Here's another one. I'm curious if people just did it this way and they thought to themselves, well, we don't even really need this. If I just start at 0 and count by 2s, I can do an odd number, it'll still work. Who here did it like this? 2 people? Yeah. Just another way of doing the same thing. Just instead of checking if the number is even, I just ensure every number is even from the get-go. Starts at 0. Is 0 less than or equal to n? Yeah, okay, add it to the running total, and then increment by 2. So now it's 2. Is 2 less than or equal to n? Yeah, etc., etc., etc. So there we go. Cool. Any questions about this alternative? One's not better than the other. They're just different. No questions about it? Everyone likes it? Who here likes the first one better? Who here likes the second one better? All right. To each their own. That's all. And I guess everyone else just doesn't have a preference either way, right? All right. So, any questions about those while loops before I get to the next thing? So, you may have noticed something about strings. They're a little different than the other types we have. They're different from ints, booleans, floats, because what's interesting about a string is, you know, if I have a variable and I'm putting an integer in there, a variable can only hold like one piece of data. Right? So let's say I have a variable for an integer, and the variable is going to go right here in this seat, right? That seat is enough space to store an integer as far as the computer is concerned. So when I have a value, an integer, I want to save it, I can put it in this seat and the computer's happy. The problem with strings is, like with integers, a computer says, okay, I want to use like 8 bytes to store the integer. Yeah, I'm going to use 8 bytes to store the integer, meaning I know exactly how much room I need to store my integer. 8 bytes is going to be enough inside the computer. Don't worry too much about what a byte means, but there is just some finite amount of physical space that the computer is happy to store an integer. We can have numbers that can get bigger than the 8 bytes would allow, but there's some tricks for that. But for our purposes right now, traditionally speaking, we have 8 bytes. We want to store a computer in 8 bytes. So maybe each of these chairs represents 8 bytes. A float, same deal. A Boolean, we don't need 8 bytes for a Boolean, but we still really only need a finite amount of space, a finite, well-understood amount of space to store a Boolean. A Boolean is a 0 or a 1. But strings are funny, because you can have a string that says hello, and then you can have a string that is the entire contents of your favorite book, stored in one string. You could store a single letter in a string, you can store a word, you can store a sentence, you can store a paragraph, you can store a whole book in a single string. So the computer's got a bit of an issue. We have an engineering problem here. How much room do I need to store the string? For an integer, I know I need 8 bytes. I just need one chair. That's plenty of room. A string, on the other hand, I don't know. The string might be small, it might be big. Strings, the way the computers deal with this is it treats strings as what we call an object. It's actually a little bit different than your just regular old integer. We've got some interesting tricks for it. So when you really think about it, so if we go to an older programming language, traditionally speaking, there's another type, a character. But a character is only a single character. And it takes up, let's say, the same amount of room as an integer. So I can store a single character in one seat. Easy peasy. But if I have a string that needs 2 characters, I need 2 seats. But a variable is only good at holding reference to one piece of information based on kind of how we understand so far. And if I have a string that's like my name, I'm going to need a heck of a lot more seats. I'm going to have to keep going. So we've got like an issue here. Traditionally speaking, a string is a collection. It's a linear sequence of characters. Right? Effectively. Hello is an H followed by an E, followed by an L, followed by an L, followed by an O. So really, I would need like H, E, L, L, O. I would need 5 seats for that. It's kind of funny. And I don't know if you've noticed this. Some of you I know noticed this by accident in lab. But I could do this. I can have some arbitrary string here. Hit run. I can actually index individual letters from a string. So I have the string HELLO, comma, space, WORLD, exclamation point. And I say, give me the letter at index 0. Give me the 0th letter. Well, that's a capital H. Give me the string, the character at index 4, 0, 1, 2, 3, 4. Well, that's the lowercase o. If I change this to a 5, what would I expect to see? It's a quiz. Oh, a comma. What about a 6? What would you expect to see? A space, which won't look like anything, but I can highlight it and you can see it is there. Yeah. So I can actually index these things, which is neat. Now, I think I've already told a lot of you, but just be aware that indexing starts at 0. The thing at index 0 is the thing at the beginning. Think of it as offsets. Go to the beginning of the string and take 0 steps. Where am I? Well, I'm still at the beginning. That's how you can think of it. So here, I'll give you a few minutes to do this activity. Just follow these steps right here. I'll give you a few minutes and see what you can get going. Raise your hand if you're done. Raise your hand if you'd be done in like 20 more seconds. Okay, take the 20 seconds. Yeah, here's a neat one. You can actually ask the length of a string. You can say, hey, what's the length of the string? LEN for length. You can index strings backwards to go in reverse. The last one is the exclamation point. -0 is just the beginning. It's not a thing. There is no such thing as -0, right? It's just 0. And you can also do the slicing. This is called slicing. It's a Python thing. Not a lot of programming languages have it. It's just syntactic sugar to mean give me all the values from index 2 up to, but excluding index 6. So if we look at the string 0, 1, 2, well, that's the first L. So 2, 3, 4, 5, but we don't include the space. It doesn't include the last value. So it includes 2, 3, 4, 5. What's kind of neat is what's the difference between 6 and 2? Well, that's 4. It'll print out 4 values, but it's because it starts on the 2. 2, 3, 4, 5, but not the 6. So we get the 4 values. All right, here's all the way up to 8. And here's another neat thing about slicing is you can actually add a third one that says and count by 2s or count by 3s. If you leave it blank, here, let me show you. If I do, that means start at the beginning and go to index 6. Start at index 6 and go to the end. If you leave it like this, it means give me everything, but this is an easy way to make a copy of something. The reason we want to make a copy of something like this is going to be made a lot more clear in like 2 topics. Any questions about this? Just some neat little things you can do. All right, so we saw while loops. But there's another type of loop. And if you've been working on assignment 1, yeah, you've seen it. It's a for loop. But first and foremost, let's say I want to write some code that prints some characters out to the screen. Right? Okay, I just run it. So what will this code do? Well, I give this code, this function is expecting some string. Right? When you look at the type in some string. It doesn't actually return anything, it prints. This function has a side effect. That's okay for demonstration purposes. So what does this code do? Well, it starts with the character index equals 0. While the character index is less than the length of the string, print the string at index 0, and then add 1 to the index. So when I actually call this, what do we expect to see? So let's say vertical. We see the string printed out 1 line at a time. Why? Well, first of all, here's an interesting thing I want you to observe, because this is going to be the way it is for the rest of your career in programming if you continue. You might look, while character index is less than the length of the string, and you might think for yourself a second, you might think to yourself, hold on, shouldn't it be up to and including the end? of the length of the string. But let me ask you this. What is the length of the string howdy? 5, right? No, there's no trick there. So on line 9, when I ask the length of a string, it would be 5 in this particular case. What index do we start at, though? What is the last index that actually exists in that string? 4. There is no index 5. The length of the string might be 5, but there is no index 5 because it starts at 0. 0, 1, 2, 3, 4. I only counted to 4, but how many fingers am I holding up? 5. That's why it's less than length, not less than or equal to, because we start counting at 0, and there is no, your string could be length n. Arbitrary length, it's n. The last index will always be n minus 1. There is no index n. In fact, if I try to ask, what do you think is going to happen if I go up, let's go back here real quickly. So what is the length of the string? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So if I say len of A, I should say 11. So if I say, give me A at index 0, I get the H, right? If I get A at index 11, it doesn't work. Index out of range. There's nothing there. So if you ever have a string length of n, whatever it is, the last index is always n minus 1 because index 0 is there. Okay? So that's something to remember because that's going to be the way it is for the rest of your life. Also, just to be clear, I can index a literal string. There's really not a lot of utility in that, but I could, just to make sure you're aware of it. So back here, when I gave it howdy, what happens? Character index is 0. Is 0 less than the length of the string? Is 0 less than 5? Yep. All right, print out a string at index 0. That's the H. Add 1 to the character index. Character index is 1. Is that less than 5? Yep. Print out the string at print out the letter at index 1 of the string. Add 1. Is 2 less than 5? Yeah, print out index 2. Is 3 less than 5? Print out index 3. Is 4 less than 5? Yeah, print out index 4. Is 5 less than 5? Nope, we're done. That's what's happening there. So what do we have? Well, it's a while loop. It's just a counting while loop. We want to start at 0 and count up to some specific number. So we've got this counter variable. Well, we check it's less than the length of the string. And then we add 1 to the counter at the end of the loop every time. That's all. This looks familiar to the loops we've seen so far, the while loops we've seen so far. Now, the while loop, perfectly fine. There's nothing wrong with this while loop. If I gave you this problem and you gave me that code, you'd get perfect. It's great. But there exists something called a for loop, which syntactic sugar. For loops are great for when we have a collection of things and we want to do something for each of those things in the collection of things. So the while loop will loop based on any Boolean condition. A while loop is very general. A for loop will loop over each thing in a collection of things. For each character in a string, because a string is just a collection of characters. For each Starbucks location in a collection of Starbucks locations. That's what a for loop is. With that in mind, we could actually write the same function a little easier. Oops, 1. Look at the difference. It's quite different. They're both the loop, but I don't need a counting index anymore. I don't need to update it. I don't need to check a condition anymore. No. This will run for each character in the string. If I give it the string howdy, this loop will run a total of 5 times, starting with the character at the beginning of the string, and then to the next character, and then the next character, and then the next character, and it stops running when it runs out of characters. So the first time through the loop, now, I also want to mention something here. Right here, with this syntax, pay attention, because this throws people off, and I don't want to have to repeat this 100 times. A string is the name of the collection of things. This is the value passed to the function as the parameter. This right here is an arbitrary variable name that I'm going to put each thing into. Here I called it char because it's a character, and that's a good thing. The fact that it's called char, entirely arbitrary. I could call it It really doesn't matter. Obviously, give it a good name, but just to prove the point is it really doesn't matter. Okay? So I'm going to go back. Oops. The first time through the loop, char will have what value in it? 0? H. It doesn't even need to count. It doesn't care about counting. It's going to do each thing in the collection of things. So char, the first time through the loop, will be the letter H. It prints it out. All right, we're done. Next time through the loop, what will char be? Oh, next time through the loop, what will it be? Then what? And then what? I don't know if everyone's quiet because they're not following. If you're not following, you're in big trouble. Like if it doesn't make sense to you, you better make it make sense. It's for each thing in a collection of things. Starts at the beginning, works its way to the end, and when it gets to the end, it stops. That's all. If I go, we can get rid of this. I can put a literal in here. We will see Q, W, E, R, T, Y. First time through the loop, thing is Q. Next time through the loop, it's W, E, R, T, Y. All done, gone. Now here I put a literal in here. It could have been a variable. There. It doesn't matter. What's neat too about this is a very general thing. It's for each thing in a collection of things. The collection of things can be whatever. Now at this stage we don't know of a lot of those, but we're aware of strings, which is really just a collection of characters. And from assignment 1, you're kind of aware of lists, where you have a list of Starbucks locations, so for each Starbucks location in the list of Starbucks locations. For each character in some string. A for loop lets you run that code for each thing. I didn't need to index anything here anymore, which is kind of nice. The loop kind of took care of that for me. Any questions about this? Yes? Not in a nice way. Like if you wanted, you could really do whatever the hell you want to do, but that would be, you'd have to get really hacky to make it do something like that. So let's not worry about it. In general, with easy, nice, easy syntax like this, no, but there are ways to do that. Yeah. I thought I saw another hand. Was there another hand? No, everyone's okay with this. All right. The while loop will continue to run while some condition is true. The for loop, it's different. It runs for each thing. When it's out of things, it stops. If I were to call vertical print for hello, all right, this is just explaining what I already explained. And this is just saying it really doesn't matter what you call this. For some variable name, that'll be where you store the current thing in some collection of things. Here it's called a string. All right? So, one might think to themselves, if I can say, if I can index the string and get a value from it, can I do this? Take a look at this code and try to figure out what I'm trying to do. What am I doing? Yeah. This code looks like what I want to do is I want to say, okay, go to the string at index 1, and I know there's an O there, but forget it. Put an X in there. All right? That's what this code is going to do. Or at least it's going to try. But it's not going to work. Because strings are what we call immutable. Immutable is a fancy way to say you can't change it. And you all got a mute button on your TV. You know, you hit it, you change your TV such that it stops making noise. Well, imagine your TV was immutable. You can't mute it. You can't do anything to it. It's immutable. Your other variables are mutable, kind of, right? Like you can go to a variable and change whatever value's in there, right? But a string's a little different. Now, to be clear, the variable example is actually quite different in reality with what's happening. And we're going to talk about this shortly in the course. But we can't actually go into the string and change it. Now, you might say to yourself, what if I really want to make it different? What if I really do want to change that string? Well, you can't. But what you can do is make a new string based on the old string with the difference you care about. Let me show you. If I there. This right here, let's get rid of this, will actually make a whole copy of a string. But I don't actually want that. I want a string at index 0 plus the x plus a string at index 2 to the end. So what am I doing? Is I've got the string, a string, howdy. I'm going to new string, and it's going to be a string's index 0 plus x plus a string from everything from 2 to the end. Print out a string, print out new string. So we see howdy is left alone, but I was able to change that string. Although I didn't actually change it, I just made a whole new string with the change I wanted. But the original string was left alone. Now, I also want to make sure something's clear to you. I can say, and do this, and now you think to yourself, well, hold on, you just said you can't change the strings. Well, I can change what the variable references, but I can't go to the string in the variable and modify the string. So the variable can change to like, oh, you held howdy and now you're holding not howdy. But I can't go to the string, go to an index at that string and change something about the string that's there. I can make new strings. Any questions about that? All right, I'll see you later.